This is Venus. Venus is the second planet in the solar system. Also, is Earth's twin. That means that Venus has similar features and history with our home planet. But there is a catch. While Earth has a rich temperate atmosphere with normal temperatures, Venus has a super hot temperature and hyper pressure between its atmosphere. That is because Venus is near the Sun, as you can see in the red zone. In comparison, Earth is in the near green zone, just between the red and the green, and Mars between the blue cold light zone and far green. That difference means a lot, as you can imagine. Despite this, Venus might be suitable for life in certain regions. In this video, we present two hypotheses of how Venus might have life beneath its hell-like surface. First, we must establish some parameters of what's going on Venus. As I said before, Venus has almost 32 times the mean temperatures of Earth's surface, also 92 times the atmospheric pressure. In addition, a day in Venus lasts 224 Earth days, triggering hot spots near the equator, as you can see in the top right figure. So, you should be questioning how life can survive on Venus, and I shall answer: beneath the surface. If we take out the atmosphere and look to the surface, we can find suitable places in the poles to sustain underground bacterial life. We know that many years before, Venus had at least 150 times as much water as it does now. This statement was reported in 1993 by the planetary scientist Thomas M. Donahue due to the abundant presence of deuterium, a hydrogen isotope. If we continue the water trend, the life on Venus might have spawned in the Ocean period. Just like life on Earth, in the past, Venus might have produced Coacervate, a precursor of cells proposed by the biochemist Alexander Oparin, and then changed to suit the extreme conditions of the planet, like the thermophilics of the Yellowstone National Park.
Recently, there has been new information from the Nature Astronomy Journal that reveals the presence of phosphine in Venus, raising the possibility that there is something unusual going on in the planet's atmosphere. If we take this in consideration, the presence of life in Venus doesn't seem so crazy. As shown in the graph, there is no data about the presence of phosphine in Venus' atmosphere. The elements reported are majorly carbon and sulfur dioxide, while the other two-thirds of the elements such as water vapor, helium, and nitrogen represent less than 10% of all the elements. Considering this, the presence of even a few parts per billion of phosphine is completely unexpected for an oxidized atmosphere. Every possible scenario that could establish the presence of phosphine was revised. With the use of the GMCT and ALMA telescopes, the abundance of phosphine in Venus's atmosphere was estimated. As shown in the graphs, this information was acquired by comparing a model line to the radiative transfer in Venus's atmosphere, also by getting single-line millimeter waveband spectral detections from the GMCT and ALMA telescopes. Even though the amount of studies made were really exhaustive, the presence of phosphine in Venus is still unexplained. We now currently known abiotic productions of rods in Venus' atmosphere, clouds, surface, and subsurface, or from lining, volcanic, or meteoric delivery. Phosphine must be produced by a process not previously considered plausible for Venusian conditions. This could be unknown photochemistry or possibly life. Despite the lack of information, the presence of life in Venus is now a very important possibility to consider for the future. Finding life in other planets is closer than we think.